Students, welcome again to another episode of SB Maths class. We are discussing about the relations and functions, and at the previous two videos we have discussed about the graphs of some important functions. Now, today we will discuss about the types of functions but according to the mappings of the functions. So, according to the mappings, there are four main types of the functions: into, onto, one, and many to one. So we will discuss in details about those functions and we'll show some examples of those functions also. So students, let's get started. First one, the first function we'll discuss about, number 1, that is 1 to 1, or it is called as injective. One or injective function. What's the definition of the injective function? Definition: a function f a to b is called injective if here at the name of the function only the definition, you can imagine the definition from here. So if a to b is called injective if for different elements of set A have different images at set B. If A to B is called injective if for different elements of set A have different images at set B. That means none of two elements of set A will associate with a single element of set B. What will be the arrow diagram? If those are two sets A and B, if those are some points, then the function will be look like this. That means one element of set A will associate with only one and only one element of set B. This is the arrow diagram. Now, if we want to say this as analytical representation, or analytically if we want to say, then for x1 not equals to x2, f of x1 will be not equals to f of x2. Or you can say with equal to also, or I am saying like that, x1 equals to x2 implies that f of x1 equals to f of x2. This is the analytical definition of the 1 function. Now, if we want to say graphically, that is, what is the graphical representation of 1 function? Then if we draw a line parallel to x-axis, then if that line parallel to x-axis, if that line intersects at one and only one point to the graph of a function, then we can say the graph is of one function or injective function. I am just writing in short: a line parallel to x-axis intersects at only one point. How it will be look like? like this. If we draw the graph of say y equals to 2x, I am taking that function y equals to 2x. So the graph will be look like this, y equals to 2x. Now draw a line parallel to x-axis. So if we draw this one parallel to x-axis, or if we draw this one parallel to x-axis, then just see those lines intersecting at only one point. This line is intersecting at this point, this line is also intersecting at this point. So this graph y equals to, or this function y equals to 2x, this is the function of injective, or this is an injective function, or injective mapping you can say also. Number 4, number of injective functions, or number of functions I am writing here because I am discussing about the injective. Number of function I am writing here. Number of function, that is number of injective functions. If cardinality of A equals to M and cardinality of B equals to N, that is in A M number of elements are there, and whereas in B N number of elements are there, with the condition N is greater than M, then I am writing here like that, when N is greater than equals to M, then the number will be N P M. Actually class 12 students knows this one. This is the permutation NPN NPM, and class 11 students just note down this one. This is the permutation. Actually it will be like this: factorial n by factorial n minus m. If you don't know the factorial, just keep in mind it will be like that: n into n minus 1, so as n minus m plus 1. This is the total number of the injective functions, and if n is less than m, then the number is 0. So this is the total number of functions and other things. Now the testing, how you will test if one graph, actually the question comes like that: one function will be given to you, and then you have to check that is whether that is the 1 function or 1 function or both of these, like that. So here we have taken y equals to 2x. How to check? So checking. Number 5, checking. We have taken y equals to 2x. Just see the analytical definition. Y equals to 2x is there. I am writing like that: fx equals to 2x. Now I am writing like that: let x1 not equals to x2. That means 2x1 is not equals to 2x2. It is the obvious case. So whenever this will hold, we can say f of x1 is not equals to f of x2. So according to the analytical definition, we can say this function fx equals to 2x is injective. Actually very much easy. The concept is very much easy, but little bit confusing. I am doing with the injective function now, that's why it is looking like very easy, very easy. Is it a concept only like this? Some arrow is there and this is being proved. But whenever you will see, I am just approaching to other functions, and whenever you will see those functions, then little bit confusion can come. That's why just note it down, pause the video and note it down. After that I am going to the next functions. Now students, the next function is many to one function. Actually from the name only you can say that is what is the many to one function. Two elements of the set A can have or may have more than, two elements of the set A will have one image. Not two, actually more than one elements of the set A will have one image at the set B. Let us see what is happening. I am writing in short, that is if A to B is many to one when more than two elements of A have one image at set B. What will be the arrow diagram here? If this is the set A, this is the set B, then the function will be look like this, like that. That means here just see two functions, two elements of the set A is associating with one element of the set B. So seeing this graph only, seeing this arrow diagram only, can you say me one example of many to one? Actually the constant function is the best example of many to one. Whatever the terms or whatever the elements you are taking at set A, all the elements are converging or associating with one and only element of the set B, that is the constant one. I have shown you the graph of the constant function at the previous videos. Now the analytical definition. Here for x1 not equals to x2, we can say f of x1 will be equals to f of x2. That means two different elements, x1 and x2, two different elements, they are associating with one element of the set B. Graphical representation, same thing. That is, if we can draw one line parallel to x-axis, then that will intersect the graph of the function at more than one point. Then that can be called as many to one function. Let me say that one, that is a line parallel to x-axis will intersect at more than one point. As for example, if we want to take say fx equals to x square. If this is the function fx equals to x square, then just see, if we draw the graph of the function, you know the graph will be look like this. If you have not seen the previous videos, just pause the video and also go to the previous videos and see. In my channel all the videos are there. So this is the fx equals to x square, the graph. Now if we want to draw a line parallel to x-axis, just see at this point and this point, this line is intersecting the graph of the function. That's why this is the many to one function. Okay. Now number of functions, actually same thing, cardinality of A is m and cardinality of B is n, where n is greater than m or greater than equals to, you can say, then the number will be n to the power m. That is, number of many to one function will be n to the power m. how to check? Go to the analytical definition here. Actually, one thing you have to keep in mind, that is, for showing one function, or I want to say that is for showing a law that is not universal, for showing this type of law, I am saying for all the laws or for all the results, that is, you have to show that is not universal. Some exceptions are there. Then just take that exception and show that this is happening, that is, we are not we cannot show that law is universal. Then you will prove that one. What I want to say, that is, here x1 not equals to x2, that is fx1 equals to fx2. If we say that is law of contradiction, if we want to say that one. So x1 not equals to x2, I am writing like that, let x1 not equals to x2. Then this one, x1 square not equals to x2 square. Can we say this one? We cannot say, because sometimes it happens minus 1 squared is 1 and 1 squared is also 1. Minus 2 squared is 4 and 2 squared is also 4. So from this we cannot say this one. That's why I am saying that just take one example for those cases. Take one example. I am taking, that is, let the function fx is defined on integer, set of the integers. Then for minus 1 and 1, for both those points, f of x will be only 1. For minus 2 and 2, f of x will be 4 only. So just see, 2 points are associating with 1 point here. If we want to draw the arrow diagram of this particular mapping, then this is the set A, this is the set B. Actually both are the subsets of the integer set. Then if I take here minus 2, minus 1, 0, 1, 2, and here I am taking 0, 1, 2, 3, 4, like that. I am writing their names, minus 2, minus 1, 0, 1, 2. Here 0, 1, 2, 3, 4. If this is the condition, then just see, minus 2 is going to 4, minus 1 is going to 1, 0 is going to 0, 1 is going again to 1, and 2 is again going to 4. Just see, it is the perfect example of many to one function. Okay, so students, jot it down.